and then we'll come back to some of those little nuances like that. All right, because we're really close here. Okay, I have one more major headache concept, and then we will have a program written. All right, the major headache concept is a shift register, and you do not see this in other programming languages. It is an artifact of the way variables are in a graphical programming language. Okay, so let's just first of all talk about this block diagram here and how things are going to execute. Well, when you do a text language, a text-based language, how does the code execute?
Top down or
Top down every time, and you've got functions, and you might call functions, so it might kind of zoom through to the function and zoom around that way, but within the function it's going to go from top to bottom every time, every language. I have yet to see the one that goes from bottom to top. That maybe there's one out there, I don't know. LabVIEW goes, it comes from the outside and it goes in. The convention is left to right, okay? Left to right, but let's just leave it at left to right. Because if I put something out here, and like if I put let's just create a new, let's just to add confusion, because you guys are sharp enough to wonder about nuances like this. All right, so I'm going to do create indicator. It's not cooperating with me. There it is. Create indicator. How come it's not giving me indicator? It's probably have to do it. Okay, there you go. Okay, so now I've got this, one of these numerics. I got this numeric here, numeric 2 going to numeric 3, and it's not wanting to move this one. There it goes. All right, numeric 1, numeric 2, and numeric 3. These two, one goes to the other, and then these two are just feeding into my loop here. One of them is the loop iteration. So which one happens first? Does this happen first, or does this happen first? Which way does it go? LabVIEW might do it either way. Is the real answer. It's not deterministic because you haven't explicitly told it. You will have to, if it's important to control which way that happens, and a lot of times it will be, you'll have to explicitly control it. You will use that sequence thing that I was showing you earlier. That's how you would do it. And there's a couple different sequence structures. But let's not worry about that right now. That's really, I want to show you one other thing that's important to do. You can go to these, see these icons like this, the size of these boxes in your block diagram. This is no good. If you were to do this at National Instruments, people might hurt you. These boxes are way too big. We don't like those things. So there's a way to change. See this view as icon? Uncheck it and it makes it smaller. Well, what are you going to do? Run around and do all of them? That's no good. We want them to appear when we lay them down as these smaller ones. We don't want the big ones. The code just gets too big too fast. It becomes unwieldy. So you can control that somewhere in here if I can remember. Okay, it's under Tools, Options. Don't have to remember this, but you set it one time for your copy of LabVIEW and it just stays that way from then on. So anytime you install LabVIEW, you don't have to worry about remembering this. There it is. Second one down, place front panel terminals as icons. Uncheck that and hit OK. That will fix your LabVIEW environment where it will never again give you those big, ugly things that people will hate you for it. You know, that you'll lose credibility. If you have those in your LabVIEW code, you will lose credit. People are like, oh, I gotta know what he's doing. They really will. If they see that, they will not like it. Or anybody in Austin, they'll, as crazy as that is. Okay, so I'm gonna get rid of this now. Oh, let me show you how I got rid of that. Did you see that? I just highlighted it, and you can see the ants marching, and I hit delete. Boom. All right, we're back to our program now. Okay, we took some, we kind of went off track there. I showed you some things, but let's get on through this so that we can have done a program. and hopefully you guys will be able to work from there, okay? So we've got a loop here. I've set loop iterations. I put it at 10, so we know we're going to do 10 iterations of the loop. Now what I'm going to do is I'm going to right-click on the edge of this for loop. I'm going to say Add Shift Register. This is the thing that's a headache that you've got to understand, and it is weird, and you've never seen anything like this in another language because you don't need it unless it's data flow. This is data flow programming, by the way. It's what they're calling it, or G, graphical programming. The shift register is the way to maintain the variable aspect of the variable when you do the same thing over and over. You can't go left to right over and over again. If you were to do it in C, the variable would just retain its value, right? How do you get, in data flow, it's got to go left to right. So if I were to take this wire and just go all the way to the other side with it, if I can get the wiring tool, LabVIEW, please. Here we go. If I were just to go all the way to the other side of it, upon iteration or the second iteration, what comes out of the edge there? The answer is the value may have changed, as it went through. It would have no way to retain that. Does that make sense to anybody? Or you guys aren't LabVIEW programmers, so maybe that is just like, yeah, whatever you say, dude. But with data flow, everything has to be explicitly called out on both sides of the wire for it to execute. What it's going into the wire and where it goes every time for every iteration. So that's what the shift register is for. So what I'll do, because I took this numeric and I'm going to I put a 2 in and I'm going to want to multiply it by 2 for every iteration of the loop. What I'm going to do is, instead of doing it this way, which will not work, actually I'll show you it will not work, and then that will justify the use of the shift register. Okay, so let me delete this. Once we get through this one, guys, you should be able to do some programming. So, because these are the key elements that you're going to need. All right, so I'm going to insert into this wire here. Say insert